Hi everyone, this video is on question 9 of exercise 9G of PO2. So we have a parametric equation and in part A we want to find the coordinates of P. So just a quick recap. Whenever we have parametric equations and we want to differentiate them, we need to use the formula that divide dx is equal to divide dt divided by dx dt. So that means we need to find divide dt and dx dt first, and then find divide dx. And by having divide dx, we can answer part A. So divide dt is equal to, the derivatives are very simple. So x is equal to t squared plus t. That differentiates to 2t plus 1. And dx dt is equal to, I meant dx dt is equal to 2t plus 1, because I was looking at x and I mistakenly wrote y here. And now for divide dt, it's 2t minus 10. Now we can find divide dx. So divide dt is equal to 2t minus 10, and dx dt is 2t plus 1. So this is the derivative. And now when we look at part A, it says find the coordinates of P. And the crucial piece of information here is that at the point P, the gradient of C is 2. So another thing to remember is that normally in parametric differentiation, we are given the value of t. That means when we find divide dx, we substitute the value of t to get the value of the gradient. But in this case, we have the gradient and we want to find the value of t so that we can then substitute the value of t into the equations of x and y to get the coordinates of P. So that means in order to find the value of t, we solve this equation, right? Because we want to know what's the value of t, and the gradient is 2. So what's the value of t when gradient is 2? So we can now do a cross multiplication. 2t minus 10 is equal to 4t plus 2. This is equal to 2t is equal to minus 12. That means t is equal to minus 6. Okay, now we have the value of t. We just need to substitute this into equations of x and y to get the coordinates. So when t is equal to minus 6, first x is equal to, x is t squared plus 6. So that means minus 6 squared plus minus 6, or just minus 6, which is 36 minus 6, and that's 30. So that's the x coordinate. The y coordinate is equal to t squared minus 10t plus 5. So that's 36 here. Then here is 60, and then 5. And it's equal to 101. And this is our y coordinate. So the point P has coordinates 30 and 101. So that's part A, the answer to part A. Okay. Part B says find the equation of the tangent to C at point P. Right, so now we have the point P. We know the gradient at point P, which is, the gradient at point P is, I guess 2. Yeah, that's 2. So we have the gradient, we have the point, and we can now find the equation of the tangent very easily. Y minus y0 is equal to m times x minus x0. So y0 is 101, m is 2, and x0 is 30. So we get y is equal to 2x minus 60 plus 101. Y is equal to 2x plus 41. So this is the equation of the tangent. So equation of the tangent at point P. And now finally part C. So part C is actually the most interesting part of the question. So it says, show that the tangent to C at point P doesn't intersect the curve again. Okay, so we first need to understand what's going on, because we obviously know that whenever we have a tangent, again, this is a random curve, by the way, but overall, whenever we have a tangent, that must intersect the curve at only one point. Now, in this case, we want to show that, and just yeah, show the fact basically, because normally we just use that, but this time we want to show that that's true. So what we do here is actually using the equation of the tangent. So the equation of the tangent is y is equal to 2x plus 41, right? Now what we do here is that we first substitute the values of x, I mean the functions x and y, which are in terms of t, into the equation of the tangent, and then we try to solve that for t. Now the reason we do that is because it's all about the value of the discriminant, because remember the discriminant tells us the number of roots, and in this case, if we manage to get more than one root, then that means the tangent intersects the curve at basically more than one point. But we are hoping that's not going to happen, because we just want to show that it only intersects once. And so we are aiming to show that the discriminant of that equation is equal to 0, because when the discriminant is 0, that means there is only one point of intersection, or one root to the equation. Okay, so that's the logic here. And in this case, y is equal to t squared minus 10t plus 5. And then x, the function x is equal to t squared plus t. So 2 times that t squared plus t. And finally plus 41. So now we can do t squared minus 10t plus 5 is equal to 2t squared plus 2t plus 41. Then we can simplify this. So, or rearrange that. Then we have minus t squared. Then from t's, we are going to get minus 12t. And then here, minus 36 is equal to 0. Then we can multiply this by negative 1 just to get rid of the negatives. So we get t squared plus 12t plus 36 is equal to 0. And then at this point, we can find the value of the discriminant. So the discriminant, which we can show with delta, but that's not important if you don't want to, is equal to b squared minus 4ac, which means we have 12 squared minus 4 times 36 times 1, which is 144 minus 144 again, because 4 times 36 is 144, and we get 0. And this is exactly what we were aiming for. So thus there is only one solution, and which means we only have one point of intersection. So there is only one point of intersection. And that's exactly what we wanted, right? So we wanted to show that the discriminant is 0. Therefore, there is only one point of intersection. So we have proved what we were asked to do so in part C. Okay, so that's it for this video, and thank you for watching.